Welcome to another video lecture. In this video lecture, we are going to discuss about the time response of a control system. So we are going to discuss in this lecture what is the time response of the control system, what is the transient and the steady state response of control system, what are the different test signals which we can apply to the system to get the response of that system. And in the end, we will also discuss the transient analysis of system with the different order of the system. So let us first start with the time response of the control system. So what exactly is the time response? Basically, this is the response. Let me write here. It is the response of a system to the applied excitation. So suppose we have a control system here and we apply some input or excitation and we are getting some output which is the control output. Then how this the response of the system varies with respect to time is the time response of the system. Obviously, it is in the Laplace domain. So first we need to convert this into time domain by taking the inverse Laplace, and then if we plot this Ct with respect to time, then how this Ct responds or how it varies with respect to time is the time response of a control system. Now the time response of control system we can divide or we can categorize into two parts. The first one is the transient response and the second one is the steady state response. Now to understand the transient and steady state response of control system, let us take one example. So here I am considering a simple pendulum system in which a bob is suspended by a thread. Now this bob is released from some height, and as we know that it will oscillate around its mean position. So it will again go to this position and come back to this original position, and it will oscillate around this mean position. Now let us suppose if we want to draw this distance with respect to time, this distance with the mean position, suppose initially it released from distance d from the mean position. Now if you want to plot this distance with respect to time, and suppose this is the mean position here, this is the mean position. So now I'm releasing it from, suppose let's say distance d from here, and at t is equal to 0 I'm releasing it from here, and at t is equal to t1, it reaches to its mean position. Now at t is equal to t1 it reaches its mean position, which is this. So this will go like this, and after t is equal to t2 it goes to another end, and let us suppose this distance is d1. It will not be same because of the air friction, it will not be same. Let us suppose this distance be d1, so it will again go to some distance d1 after time t2, and it will keep on oscillating, and at each time the amplitude or magnitude of this distance will keep on decreasing because of the friction, and it will reaches to its mean position after a certain time. Now let us consider that after let's say infinite time it reaches to its mean position, but because of some irregularities it appears or it stabilizes at some deviation from mean position. Let's say that deviation is delta d. So this distance will never be equal to this mean position. There will always be a deviation. Let's say that deviation is delta d. Now in this response of this simple pendulum, until when we are getting the dynamic change in the distance with respect to time, that response is known as the transient time. And after transient time, when the response stabilizes, let me draw it here. After this, when the output is stabilizes, this response is known as the steady state response. And this deviation here is known as the steady state error. This deviation here is known as steady state error. So let me summarize once again here. So the transient response is the response until there is a dynamic change in the output with respect to time, and after the transient time, when the response stabilizes, we get steady state response. So this is how we can classify the different time response of a control system. So transient time is the time until we get dynamic response of the system, and steady state after transient time when system stabilizes. So these are the two type of time response we get. Now let us discuss different test signals which we can apply to the control system. Now remember once again that suppose this is a control system and we apply some input and we are getting some output, and this output is can be divided in two parts, the steady state CSS and transient. So in order to test different steady state values and different transient response, we apply different type of inputs here. So what are those different type of inputs? So the first type of input is the sudden input. Mathematically it is defined as the unit step signal, which is denoted by ut, and mathematically it is 1 for t greater than equal to 0, and for t less than 0 it is 0. And the Laplace transform of this ut, as we already know that this Laplace transform is 1 by s. So the first input is sudden input, and the Laplace transform of this sudden input is 1 by s. The second input is the constant velocity input, which is mathematically is a unit ramp signal denoted by RT. So this is t for t greater than equal to 0, and for t less than 0 this is 0. And we know that the Laplace transform of t is 1 by s square. The third input is the constant acceleration input, which is denoted by a unit parabolic, and input, which is denoted by pt, which is mathematically defined as t square by 2 for t greater than equal to 0, and for t less than 0 it is 0. And the Laplace transform of t square by 2 is 1 by s cube. The fourth input is basically used for the testing of the stability of the system, which is unit impulse signal. This is known as the sudden shock. Let me again erase this and write it here. Unit step signal is known as a sudden shock. So this input is sudden shock unit impulse signal. It is denoted by del t and defined as is equals to 1 at t equal to 0, and otherwise it is 0. And the Laplace transform of unit impulse is 1. So these are the 4 different type of test signals we generally use to get the transient and steady state response of control system. Out of these four signals, test signals, these two signals, the constant velocity and constant acceleration signals, these two signals are the unbounded signals. Let me write here, these are the unbounded signals, and these two, the sudden input and the sudden shock, these are the bounded inputs. This is also a bounded input. Now, as I already told you in this discussion, that these three signals, the sudden input, the constant velocity input, and the constant acceleration input, generally we use for get the steady state and transient response of control system. And this fourth signal, sudden shock, generally we use for testing of the control system, to get the stability, to test the stability of the control system. Now let us briefly discuss the transient analysis of system with different order. So we will discuss the transient analysis of the first order system and the second order system. But as we go on increasing the order of a system, the system becomes quite complex, and it is difficult to analyze the transient and steady state analysis of system with higher order. So we will discuss the transient analysis of these two systems, the first order system and the second order system. So what exactly is the order? So if we define the transfer function of a system, which is the Laplace transform of the output divided by input, let us suppose let us take the general expression for this, Bm s to power m minus Bm s to power m plus Bm minus 1 s to power m minus 1 plus up to B naught divided by a n s to power n plus a n minus 1 s to power n minus 1 plus up to a naught. Now this is the denominator term in this transfer function, also known as the characteristic equation. This is characteristic equation. Now the highest power of s in the characteristic equation is the order of the system. So let me write it here. The highest power of s in the characteristic equation is the order of the system. So in the first order system, the highest power will be 1. In the second order system, the highest power of the system will be 2. Now the general expression I am writing here, the general expression of the first order and the second order system, and then we will end this lecture, and in the next lecture we will discuss the first order system, what is the transient analysis of the first order system. So I am writing the transfer function, the general expression of the transfer function of the first order system, which is given by this expression 1 by Ts plus 1, and the transfer function, the general expression of the transfer function of the second order system is defined as omega n square s square plus 2 zeta omega n s plus omega n square. So in the next lecture we will discuss the analysis, time response analysis of the first order system. Thank you.